Welcome to Uptime Spotlight, shining light on wind energy's brightest innovators. This is the progress powering tomorrow.
Welcome to the Uptime Wind Energy Podcast Spotlight. I'm your host, Alan Hall, along with my co-host, Joel Saxum. Today, we're joined by Bret Tollgaard, President and CEO of Sunrez Corporation, a pioneering force in UV curing technology. Under Bret's leadership, Sunrez has emerged as an industry leader in developing advanced UV-cured resins and composites, particularly for wind turbine blade repair. Based in El Cajon, California, Sunrez brings nearly 4 decades of expertise in UV curing technology. Today, we'll explore how their cutting-edge solutions are addressing some of the most pressing challenges in wind turbine maintenance. Bret, welcome to the Uptime Wind Energy Podcast Spotlight.
Thanks for having me, Al. Appreciate it.
Well, we know there's a lot of challenges in the repair business at the moment on using standard materials, resin systems out on blades, particularly as it gets colder in the springtime and the fall, where seasons get cut short and you still have blades to repair. Everybody always has blades to repair. So you hear about this large rush to get blades stabilized to get to the next spring. That's a big problem for the industry right now. How much of that do you see of people just saying, I don't know what to do. I can't get my blades fixed before the season? It's kind of where Sunrez comes in with UV cured materials, right?
Yeah, absolutely. Really, one of the biggest values that we add for our customers is time. And we save time in a tremendous amount of ways. One, the time for the repair window is greatly increased because we don't really require any heat to cure and kick off our UV curing resin. You can cure at much colder temperatures and much hotter temperatures without any impact from the ambient temperature or humidity. So you can cure materials a lot deeper into the season, so you're no longer constrained by how cold it is outside. It's really then at that point what kind of worker wants to get out up on top of that wind tower in those kind of temperatures.
I think a big thing there too, Bret, is, we're talking about UV cured resins being able to extend seasons, but what it can do within a season, right? So when you're talking like a major repair that you got grinding layer, grinding layer, grinding layer, and all of a sudden you're 3 weeks into this thing, a 3-week repair, if you're able to cure fast, move to the next step, that might shorten that thing down to a week. Is that possible? Is that much time savings?
Absolutely. So one of the big things that UV cure resins do is they use the light photons from either the sunshine or one of our handheld LED lamps to kick off our resin. And so what we can do is we can cure up to a 1/4 inch thick laminate in under 5 minutes. And depending on the light intensity that you have and the surface area that you're trying to cure, you can really fast track your repairs. And so we provide pre-impregnated sheets of fiber to the wind market. So you don't have to worry about mixing any resin up tower, getting the right amount on there, vacuum bagging, heat blanket, etc. We provide pre-impregnated sheets that have the optimum amount of resin for mechanical properties and adhesion to the wind turbine blade. And so what that allows customers to do is to actually peel, stick, and cure a laminate to go ahead and repair that surface really, really quickly.
And I think there's really 2 marketplaces I've seen your materials used out in the field. One is just major structural repairs that it just gets so cumbersome to do. The UV cured makes sense. The other one is I have a blade that has some substantial crack in it. And this is interesting because I ran across this in Oklahoma, of all places. Blade with a huge crack in it. And they had temporarily patched it to hold it together using your material just for a sense of speed. Like, let's just stabilize it and move on and fix other blades in the farm. We'll come back to this, which is really hard to do with existing resin systems.
Our pre-pregs in general are used in kind of 3 primary areas: corrosion resistance, not quite as applicable to the wind market, but cosmetic and structural repairs. And so they lend themselves really, really well to doing large, thick laminates, but also for smaller cosmetic things or even zippering certain cracks. So something that you might have seen where they have staged pre-pregs to kind of do some crack propagation mitigation. They're using a variety of instances, and really the technicians can get up and down tower just so quickly. And so that's where one of the big advantages of UV cure materials comes into place, is how quickly they can get repairs done.
Well, from a commercial standpoint, Bret, I mean, there's a lot of advantages here. So if I'm an ISP, a blade repair company, I want to come to my clients and say, hey, we've got a way to do this faster. So, this bid, maybe a chance for an ISP to get in front in the bidding process or through an RFP. And now, if I'm an operator, I'm thinking the same thing. Like, hey, this is going to be, could have been a 3-week repair, now a 1-week repair, or especially places like I'm in Canada, and our blade repair season is only 12 weeks long, and I'd like to extend it to 20 weeks or 24 weeks or something. There's so many advantages to this. Where are you seeing the most draw? Is it the operators themselves? Is it ISPs? Is it the OEMs? Where is this coming from?
So it's a little bit of everything. So historically on the wind market, we actually partnered up with GE and LM 5-6 years ago, and they were the ones who really kind of brought this material into the wind market. They saw the value in it, and at that point in time, we actually had a styrenated resin system. So it had VOCs. It was a flammable material. It was a vinyl ester based system, but they still saw the merit in being able to complete jobs extremely quick. And it wasn't that different from some of the epoxy issues that there were in the past. Since then, we've sold a little over 50,000 patches, sold tens of thousands of square meters of material into the wind market alone. And now we've brought out a new material actually in 2024. It's our 7355 vinyl ester resin system. And so it's non-styrenated, no VOC, no HAPs, all single component. And now we've introduced that into the entire wind market. And one of the things that will really help ISPs gain the confidence in the material is having some of the other OEMs come through, validate it, certified material, and really check it off saying, this works well with our epoxy or polyester blades. And so that's been our big focus for 2024 is gaining a little bit more exposure, introducing people to the material. But then we also have a track record of both, cosmetic and structural repairs in this market.
And I think that's key. And your experience outside of wind is also valuable. I know you've been helping a number of different applications, ship-based at times. Aerospace is another market you're in. Those are really helpful in the wind market also because it gives you more just world experience, world knowledge that you're bringing to the table when you come back to help the wind industry.
Yeah, absolutely. So Sunrez was actually founded in 1986. It is focused almost exclusively on UV cure resins, putties, and prepregs. And so on the decades of R&D that we've done, applications, installs, new builds, et cetera, we've gained a tremendous amount of knowledge and experience on how to really best service a customer's specific repair requirements. For the wind market, it's not that different from, let's say, marine, for instance, where you're going to be repairing composite components. So we know how to make them stick. We know how to get the right structural properties, and being able to deliver that in a form factor that technicians up tower can actually use is a big challenge, but something that we've really worked on. And think we've come up with a pretty good package.
How does the UV resin systems work? What is the magic in there? Because I've seen them over time, especially in aerospace, and now I'm seeing your material in a lot of places. What's the chemistry? What's actually happening when it says a UV resin?
Oh, that's a great question, Alan. So traditional resins, let's say for an epoxy, for instance, you have a part A and a part B. You mix them together, and then you have a certain amount of time before they start to gel and then ultimately harden. And oftentimes to really get full mechanical and thermal properties, you have to elevate the temperature and cure it in an oven, post-cure it with a heat blanket, or even an autoclave. UV cure is completely different with respect to the way things actually cross-link. And this is coming from a mechanical engineer, not a chemist. But simply put, UV curing resins have something called photoinitiator in them. Photoinitiators are activated at a tremendous amount of different ways and wavelengths. There are hundreds of different photoinitiators. And so you'll blend a specific resin and concentration of photoinitiator or photoinitiators, depending on what you're going to be curing with. But ultimately what happens is the light photons actually kick off, make the photoinitiators react then with the resin and or the monomers around them to cross-link and get a solidified part. And so you don't have any heat doing any of the work to make the resin molecules activate. It's literally all the light photons hitting those photoinitiators and going. And so what that means is you really need to pair the photo initiator with the light source. For instance, we've been doing stuff in the past where we sold to surfboard repair customers who were using a broad spectrum sunlight. That works relatively well, but you now have a broad spectrum of photoinitiators to activate. There are different ones that are good at surface curing, some that are better at depth of curing, and the light intensity, the dwell time that's going to be on that, all of that really makes a really, really big difference with respect to the type of laminate that you can UV cure.
Okay. So that explains a lot, because when you actually see UV cured resin systems kick off, they look hot. Like there's still a chemical reaction that's happening there, but the photo initiators are essentially blocking that chemical reaction until they get exposed to the specific frequency of light, and then they kind of step out of the way and the reaction happens. That is really unique, because one of the things, especially on winter blades, is that generally you're outside, so there's to be sunlight. Do you recommend just using the sunlight to cure the resin systems, or is it better to have a specific frequency light and to really get on top of it to make sure it cures out?
For the wind market in general and the type of quality that we're all really striving for, it's absolutely recommended to be curing with a specific device, whether it's one of our handheld lamps, which is something like one of these little guys. We're teaming up with the group to do LED blankets as well, or sheets that you can just wrap around it. And, it's all, there's thousands of LEDs on there, excuse me. And so there's a variety of different curing methods that can be done, but to guarantee that depth of cure and your adhesion to that repair surface, that's really recommended, because the sun at different times of the year puts off different amount of light depending on the southern hemisphere. Is the blade in the shade or is it tilted? And so you really can't control as sufficiently as you can with, an actual curing device.
Bret, when I talk to any technician that's used this stuff in the field, or even blade repair people that like, hey, have you used this yet? Here's how it works. Every one of them, either their eyes get big and they explain how awesome this, a UV cured resin was, or their eyes get big and they go, what? What is that? And that's amazing to me that not that many people have heard about it. But the one thing I wanted to share with you is I did get that was part of the feedback from some people that have used UV resins in general. And I don't know if they were Sunrez or what else is out there, but they were saying, to get clarification on how we use the lights and what light source to use. And because they're like, early days, like I tried one person said that to me one time, I tried UV cured resins on a boat one time. And they were like, when I was trying to set it up, I took a sheet off and the thing cured and I had to grind it out and fix it. So, but you guys have gone to extra steps to make sure that this thing is easy to use in the field. And you're making that process through the combination of working with GE and working with other operators and stuff. What are some of the special steps that you guys do to ensure the quality in the field and ease of installation?
One of the things that we do is we have an extensive lab here at Sunrez. We do mechanical testing. We've got, a 100 kilonewton instron for mechanical tests and coupon sampling. We have a DSC here, which is very valuable to us. The DSC will measure the degree of cure, and then also some of the thermal properties, the TG most importantly. And so what we've done in the past, and what we continue to do every time we come out with a revised formula or different fabrics, for instance, that different customers might want to use, E-glass, S-glass, et cetera, we will cure in field conditions, and then we can measure the mechanical properties of that part. Then also we can throw it in the DSC to really make sure that we're getting the full mechanical and thermal benefits of a UV curing system. So for instance, most of the time, our customers, we recommend curing with our lamp from 14 inches away. When you do that, you can cure a 20-layer UD 1000 pre-preg in under 10 minutes. That's almost a half-inch thick.
That's a day long usually, right?
Well, that's just it. And so there is a footprint, though, that LED light emits enough light intensity to cure 20 layers. As you start to go farther out and farther out, there's less light, because that LED light on the top loses some of that intensity and that focus, right? And so every LED creates a signature footprint. And then we've done all the testing internally to say, okay, from 14-inch distance, you're going to be able to cure, I'll say a nice round number, 2 square feet. Or if you go to 16-inch, you can cure 3 square feet, etc. And so we can give you the footprint that it'll cure at, the depth of cure that you can expect, and then we can do some of the adhesion properties of that as well. And so we've built a catalog with our LED equipment to really make sure it's as easy for the operators to use. And for some of the cosmetic repairs, it's 2 layers of biax, or you throw some combi in there. The sun will cure that in under 5 minutes. And so one of our LED lamps will certainly do so. And if you do have a cosmetic repair, you can put that light farther away because now you have a larger footprint, less light intensity, but you don't need all that intensity to only cure a couple layers of material. And so we try to build this structure and this guideline for customers to follow to make it as easy to use as possible.
So, Bret, we've talked a lot about the limitations of like the traditional or classic resins, the time, the workability, these kind of things that can be a pain. And one of the big items there is humidity, right? So temperature is one thing, it has to cure at a certain temperature, but there's also humidity. And when you're working in, like I'm in Austin, right? Not too far from here, there's a lot of wind farms right along the coast in Texas. And those wind farms have huge limitations because of humidity. How does the UV cured products work within that?
Well, our stuff's been known to cure underwater. So impact on curing with humidity is not that large of a deal for the material itself. Now, on the humidity side of things, what you really need to look after is what your substrate you're bonding to. If you've got standing water on there, you're going to be bonding to that standing water. And so you do need to make sure that you have a nice clean surface to actually be able to bond to. But yeah, the humidity itself won't impact the cross-linking and the curing of our materials.
And what are the costs of UV cure material compared to their non-UV brethren? Is it about the same, or is it less expensive, more expensive?
It's going to be slightly more expensive for the square foot of material that they're actually going to be purchasing based on just pure fabric and resin alone. Once again, a lot of our stuff comes pre-impregnated. We do sell liquid resins, whether it's infusion, really low viscosity, hand laminating resin. But for the wind market, we found the pre-pregs to really add the most value to the customers. And so, yeah, cost per square foot is going to go up a little bit. But when you're curing in 5 minutes versus 6 hours, and there's no mixing to do, and the technician really has to just trim out the proper size part, peel off the backing film, roll it out with a hand roller, and then peel off the UV blocking film that's on top. They save hours and hours per repair.
Yeah, I mean, at the most, repair materials are 10% of a repair. It's all most of the cost in repairing blades. It's all in just labor. It's labor, it's time. The materials is usually pretty small, so a slight increase in cost of materials will well over make up for itself in the grand scheme of things.
The ROI is incredibly short when using UV cured prepregs.
So what forms does the UV cured prepregs come in? I've seen these little patch kits that you can buy online. It's your material. It's in a 4-line package. Is that how it generally comes, or is it on rolls, or how do you expect this to show up on site?
For the wind market in particular, having a smaller style prepreg that's easier for 1 or 2 people to handle has kind of shown the greatest advantage. And so traditionally, we'll sell them in flat sheets that are 300 millimeters wide and about 750 millimeters long. And so those flat sheets are easy for people to stack, to build, and it's easy enough to overlap as well. But we've also had some more people ask us for continuous length rolls. And so now we've actually been building some 10-meter long versions that are still 300 millimeters wide. And so we're starting to get those into the field to see what feedback and stuff we have from a broader range of customers to see if that continuous length will then serve more of advantage for a trailing edge repair or something along those lines where they don't necessarily need or have the desire to continue stack and overlap prepregs.
Bret, that sounds to me like a new LEP product.
We're certainly looking in that direction, and we have a couple of things in the works that we think is going to be really, really big for 2025 on the LEP side of things.
So how's it gone in the field? Obviously, I've seen some of your materials up close out in the field, but you must be having a lot of success. If you've done 50,000 of these kits, that's a lot of kits. How is it going out there?
So far, so good. The feedback that we get from the customers is usually pretty positive. We are certainly open to understanding packaging things and that sort of stuff to make it easier for the customers to use in the field. But by and large, we've had very, very positive feedback. We've had customers install in negative 20 degree Fahrenheit weather. That was supposed to be a temporary winter repair to get them through to the summer. but it's been going now for 3 straight years without needing to be replaced. So customers like that. And then the other side of things is we've had customers like in Puerto Rico where some weather and storms were coming through, but they were to get up and down tower, fix that blade, get it spinning, and didn't have to sit there for 4 days waiting for the rain to actually pass them by. And so we get a lot of positive feedback from that standpoint, where it's just the time savings, being able to get up and down tower as effectively as possible. And so people are pretty grateful for that kind of repair opportunity.
What is generally that time savings for your materials versus the standard pre-preg materials?
Yeah, so time savings alone on, I'll call them smaller repairs, anywhere from 2 to 6 layers thick, are several hours, in the 4 to 5 hours per repair, because there's no heat blanket required, which are anywhere from 3 to 6+ hours from what I've heard. And then also it comes pre-impregnated. So all they really have to do is trim the pre-pregs to the appropriate size for that laminate schedule. And then the way that our pre-pregs come is they're formed with a backing film, our pre-impregnated fiberglass sheet. We have a clear film over the top of that. And then we have an orange UV blocking film that's just lightly spray adhesive to that clear film. And so what that will allow customers to do is peel off the black backing film, stick it to your repair surface, take a standard 3 or 6 inch bubble buster roller to roll out any air that might have been and then in between the pre-preg and the substrate. If you're building up more layers, they're going to be slightly larger than the one underneath it. And so you can always have UV protection with that transparent orange UV blocking film over the top. You can build up your layers by removing the films in between. And then when you're all said and done, you peel off that orange UV blocking film. You can leave the clear one on, so you get a nice, hard, tack-free surface. And you expose it. The sunlight will once again start to kick it off, but use that LED lamp to really get in there and make sure you get the proper depth of cure. But generally under 5 minutes, we'll tell people cure 8 to 10 minutes long for a little bit of a safety factor. But you're done curing in under 10 minutes, whereas you don't have any extra components like a vacuum bag, a vacuum itself to pull, a heat blanket to tape, and just, then wait for hours on end for that to actually go and hope that the blade is in a massive heat sink. Tons of advantages in having a pre-impregnated sheet coupled with a sub 10-minute cure.
Joel, if you're saving 4 or 5 hours per repair, how much money are you saving on that repair?
4 or 5 hours per repair, if you're talking just technician time. So let's just take it as a concept of you got 2 technicians on ropes. Each one of those technicians is going to be between $95 and $120 an hour. So we're talking, so say we make some easy numbers. We'll say $200 an hour for that rope team. And that's a cheap rope team. Yeah. So you're talking for 5 hours, $1,000. And that's if everything goes perfectly, because now when you extend time, you also extend volatility and you also extend circumstances that you may not want, right? So that's a minimum right there. Bam, $1,000. And we haven't talked about $1,000 there, but let's talk about the uptime for that turbine, because what we hear all the time, Alan, from the field, uptime is the most important thing. Uptime is the most important thing. We need these turbines spinning. So if, we're saying this is how much money you're going to save on technicians, you're also going to get 5 more hours of production out of that turbine.
Well, yeah, think about that. Someone just handed you $1,000 for changing to a better material. Would you take it? Yes, all day. I would do that all summer long. Because it makes infinite sense to do it. Yeah, I'd be glad. Please, Bret, send me more, because that's the way that this works. Is, as Joel pointed out, you're cutting the downtime of the turbine being off, but also you're getting those technicians moving on to something else. It's just a huge money savings. That's why GE Vernova and so many others are switching to these Sunrez UV systems. It's quite amazing. So, Bret, you've done so much already. I mean, you guys have been in business a long time. You're based in the United States. You're out in California. You have a long, storied history. What's coming in 2025? What should we be watching for?
For the wind market in particular, the LEP side of things is definitely one of the hot button products that we've been working on and plan to roll out. We have a couple different solutions. One there, a pre-preg solution, but then also a more putty-based option for people. We do have a couple other kind of cool UV cure products that we are working on in the wind market that we'll release in due time, but we'll keep that in the back pocket for now. But really, it's just even more market penetration. We sell UV curing resins anywhere from bathtub to surfboard repair technicians. We have some Amish folk who use it to make saddles for horses. We sell to the defense industry, marine, industrial sectors. So really, we've been a small company for a rather long time, but we're expecting some pretty significant growth in the next year plus as we get some deeper market penetration into a variety of these things. Where really we're just starting to displace other composite resin systems, mostly epoxy. We have some filament winding customers actually who had a 6 to 12 hour post cure in an oven that we got down to 90 seconds. And so when you see that kind of time savings, you're opening up more mandrels, your production lines increase, you can automate the heck out of a lot of different things. And so, yeah, we're ready for some more disruption.
Bret, yeah, you've been around the industry for a while, multiple industries. Say the industry, we're in wind, right? You've been across all kinds of composites industry. What's the craziest repair that you guys have used Sunrez UV cured repairs on?
Sunrez really started manufacturing pre-pregs during Operation Desert Storm, Desert Shield, 80s and early 90s. We had a lot of material going to the Middle East, and originally it was used for doing spot repairs on a variety of different things, but it ended up being used as a lot of armor repair. But two really interesting repairs was an IED explosion at the bottom of a Humvee. It's damaged, there's holes, it needs to be filled so it actually go and be used again. The guys in the field went up, installed our repairs underneath it, but they're out in the middle of the desert and there's no LED light. So what do? They use the sunshine and they get a mirror and they bounce the sun off the mirror to cure to the underside of a Humvee. And so that reinstated the strength.
That's super cool.
Exactly. And so that was one of the really unique things. And the other one that I heard was our materials were literally used on the leading edge of the A-10, the Warthog, to help reinstate its ability to fly. And so when you're over and you're in harm's way, they have these BDRs, battle damage repair kits. And to really make sure that you can get back home and you reinstate the ability for the airfoil to work properly, you cover all those bullet holes, and you at least now have a plane to get back home.
That to me sounds like a leading edge repair that really would work.
If it works on an airplane, I'm sure we can make it work on a wind blade.
Bret, this is amazing, and Sunrez is doing amazing things at the minute, and we appreciate you having it on the podcast. How do people get a hold of Sunrez now they've heard all this great about all the great advancements in the materials they can have for wind turbine blades? How do they get a hold of Sunrez?
Easiest place to go is the website, www.sunrez.com, SUNREZ. We're starting a YouTube channel so we can actually make some more how-to videos and ease of use things. We are same thing on LinkedIn and Instagram. We're starting it all. So the website's great. Contact us through there. Phone number's on there as well. And that'll be the best way to reach us.
Bret, thank you so much for being on the podcast. Great material. We'll see it again in 2025. Thanks so much for being on.
I appreciate the time. Thank you.